Hello everybody. So welcome back to Engineering Economics. And now we will start chapter 7, which is the annual cash flow analysis. So the contents of chapter 7 are: number 1, so we will do annual cash flow analysis when the useful life of the alternative is finite. And number 2, we do the annual cash flow analysis when the useful life of the alternative is infinite. So we can do the annual cash flow analysis for the cost, we can do the annual cash flow analysis for the benefit, or we can do the annual cash flow analysis for the annual worth, which is the difference between the uh, annual cash flow of the benefit and the I mean the annual cash flow of the benefit minus the annual cash flow of the cost. So basically what we are doing in annual cash flow analysis is computing for the A. So in the previous chapter we discussed the present worth analysis, and in present worth analysis we are computing for the P. In this chapter, in the annual cash flow analysis, I repeat, we will compute for the A. So this is the advantage of doing the annual cash flow analysis compared to the present worth analysis. So in the annual cash flow analysis, we do not need to to calculate the least common multiple of years when the alternative have a different life. For example, when we are doing present worth analysis, we have alternative A with the life of 5 years, and we have alternative B with the life of 15 years. So we need to calculate the least common multiple of 5 and 15, which is 15. So we will do the present worth analysis for 15 years for each alternative. That is for the present worth analysis. But with the annual cash flow analysis, we do not need to do that, because in the annual cash flow analysis, we are calculating cost or benefit per year. So we do not need to calculate the least common multiple of years in the annual cash flow analysis. So again, we will have two cases. Case number 1, the useful life of the alternative is finite, and number 2, the useful life of the alternative is infinite, or when n equals infinity. We will start from the first one. The useful life of the alternative is finite. So this is an example of the annual cash flow analysis when the useful life of the alternative is finite. So we have two machines, machine A and machine B. And as you can see from the presentation, we have the first cost, annual maintenance cost, annual labor cost, and the salvage value for each machine. And the life of machine A is 6 years, and the life for machine B is 10 years. So we need to do the annual cash flow analysis with the interest rate equal 15% per year. So when we are doing present worth analysis in this case, so we need to calculate the least common multiple of 6 and 10, which is 30. So we need to do the analysis for machine A for 30 years, and we need to do the analysis for machine B for 30 years. But with the annual cash flow analysis, we do not need to do that. We just gonna do the analysis for machine A for 6 years and the analysis for machine B for 10 years. So now let's do the analysis. So we have the problem here. So we will do the analysis for machine A first. So machine A, and the life of machine A is 6 years. Okay, so we have your 0, 1, 2, 3, 4, 5, and 6 years. And the first cost of machine A is 26,000. So that's a negative cash flow, and that happens in year 0. So 26,000. Okay, 26,000. And the annual maintenance cost is 800. So that starts from year 1 till the end of year 6. And that's $800. Okay, and we have annual labor cost 11,000. So that's the annual cost. So that happens every year. $11,000 for the labor cost, and the salvage value is 2,000. So as we can see from the cash flow diagram, we have negative cash flow and we have positive cash flow. So we will calculate the difference between the positive cash flow and the negative cash flow. So we're gonna calculate for EUAW. So what is the EUAW is, I need to coming back to this slide. So the EUAW, it is the equivalent uniform annual worth. So which is the annual worth. It is basically the annual worth, which is the difference between the positive cash flow and the negative cash flow. So we are calculating EUAW here because we have a negative cash flow and we have a positive cash flow. So in the annual cash flow analysis, we will calculate for A. So see the 26,000, it is a P. So it is minus 26,000, and it is and that is a P, and we need to convert that into an A. So times. So that's a P. So A over P, and the interest rate is 15%. And we will do the analysis for 6 years. So 6 and minus 800. So the 800, that is already an A, and then minus 11,000. So the 11,000, that is already an A, and then plus 2,000, and the 2,000, that is a positive cash flow, and that is an F. So we need to convert that F into an A. So that will be A over F, 15%, 6 years. And if you look up the table, and the final value that you will get is minus 18,440.8. So that's the annual worth for machine A. So now we need to calculate the annual worth for machine B. So I will draw the cash flow diagram for machine B. So the life of machine B is 10,000. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The first cost is 36,000. That's 36,000. Annual maintenance cost 2,900. Annual labor cost 7,000. Oops. Okay. That's the annual labor cost, 7,000. And the salvage value, that is 3,000. That's a positive cash flow. Okay. So now we need to calculate the EUAW for machine B. So minus 36,000. That's a P. We need to convert it into an A. So we need A over P, 15% for 10 years, minus 2,900. That's already an A. That happens every year. Minus 7,000. The 7,000, that is also an A. And plus, sorry, the salvage value should be 3,000. I put 7,000 over here, so it should be 3,000 times, that is an F, so A over F, 15% and 10. And if you look up the table and you do the calculation, and the final result will be minus 16,926.9. So I need to change this one. It should be 3,000. Okay, so see, since so this is for A, okay? So this is for A, and this is for B. So since the AUAWB is bigger than the EUAW for machine A, so EUAWB is bigger than EUAWA, so we choose machine B. So that's how we do the annual cash flow analysis. Now we will move to the next type of the annual cash flow analysis. Not the next type, but the next case for the annual cash flow analysis, which is when we have an infinite life of the alternative. Okay, so the concept is the same as what we have in the present worth analysis, when we have an infinite life of the alternative. So P equal E over I, or A equal P times I, because EUAW, it is just an A, so EUAW equal P times I. Now let's see an example. So what we have here is that the U.S. Bureau of Reclamation is considering two proposals for increasing the capacity of the main canal in their lower valley irrigation system. So that is the proposal A. So for the proposal A, that is the proposal will involve the dredging of the canal in order to remove sediment and weeds. So the equipment cost is 65,000. The life of the equipment is 10 years, and the salvage value of the equipment is 7,000. The annual labor cost is 22,000, and then the yearly cost of the weed control program will be 12,000. Remember, what they are doing here in this example is the project is an irrigation system, and as we know, the irrigation system will last. Oh, they will use it forever. So in this case, the n goes to infinity, because they will use the irrigation system again and again. It is just like the bridge, the highway system, and other government projects. That's proposal A. And proposal B, so it will involve lining the canal with the concrete, with the initial cost is 650,000, and then the maintenance cost, the minor maintenance cost a year will be 10,000, will be 1,000, and then there is a cost for lining repairs, and they have to make that every 5 years with the cost of 10,000. So we need to compare the two alternatives by using the annual cash flow analysis with the interest rate equal 5% per year. Okay. So let's see proposal A. This is the proposal A. Okay. So this is it, the proposal A. So I will draw the cash flow diagram. Now, as you can see, as we know that, so n goes to infinity in this infinity. Okay. Okay. So with the proposal A, so the equipment will cost 65,000. Okay. So we have here 65,000. 65,000. That's the cost of the equipment. Okay. So the life of the equipment is 10 years. So with the salvage value of 10,000, so let's assume that this is year 10 and this is year 0. So we'll have salvage value for 7,000. And then we will have labor costs for 22,000, starting from year 1. This is 22,000. And then the weed control program, and that will cost 12,000. Okay. So we will calculate the EUA W for proposal A, and that will be minus 65K A over P, 5% 10 minus 12K minus 22K plus 7K times that should be A over F, 5% 10. So if you look up the table, the final result that you will get is minus 41.861K. Okay. Okay, let's no, I think I need to come back to the to the to the to the problem. So proposal A would involve dredging the canal in order to remove sediment and weeds which have accumulated during previous years' operation. And proposal B, it would be involve lining the canal with concrete at the initial cost of 650,000. Okay, here it is. The lining is assumed to be permanent. So in this example, proposal A, it doesn't go to infinity. It is just for proposal B because it what the problem say. It is what the problem say. The lining is assumed to be permanent, but for the proposal B, for the proposal A, it is not permanent. So sorry for my mistake. For proposal A, n does not go to infinity. So this is the result. This is the result for proposal A. Now let's go to proposal B. For proposal B, so n goes to infinity for proposal B. Okay, we have initial cost 650,000, maintenance cost 1,000 every year, and repair 10,000 every 5 years. So what we have over here, this is the cash flow diagram for B. Okay, initial cost 65,000. Okay, 65,000. And then every year maintenance cost 10,000. So we will do that every year. And that is 1,000. And then every 5 years we will do the repair, and the cost is 10,000. So this 10,000 year 5, 10,000 in year 10 and 10,000 in year 15. Okay, so this is year 0, this is year 5, year 10, and this is year 15. And these things happens forever. Okay, so for proposal B, and goes to infinity. Now, so we need to calculate the EUAW for proposal B. So the 650,000, that's a P. We need to get an A for it, but remember n goes to infinity, so the A for the 65,000 is just P times I, which is our P is 650,000 times 650k times 0.05, and that equals to 32.5k. Okay, now this is for the 65,000. The 1,000, that happens every year and that happens forever, so no need to do anything for that. So the next thing that we need to do is for the 10,000. So we need to convert the 10,000 to an A. So what we need to do, so we have 10,000 over here. Okay, we need to convert into an A. So as you can see, the 10,000 here, it is an F. The 10,000 here, it is an F. The 10,000 over here, it is an F. So you need to convert an F into an A. Okay, so what we're gonna have for the 10,000, so that's A equal 10,000 or 10k times A over F, 5%, 5, which is, that happens every 5 years, and that's equal 1.81k. So to make it different, so we have, I'm gonna make it A2 and this is A1. Okay, the 1,000, that already happens every year, and this, the 1.81k, that's happen every year. So here from this 10,000, we convert it to an A, so it will happen from year 1 to year 5. From this 10,000, we convert it into an A, so that A will happen from year 6 till year 10, and so on and so forth. So the 1.81k will happen forever every year. So now what is the EUAW for proposal B? So that will be minus 32.5k minus 1.81k and minus 1k. sorry, what is the EUAW for B? That will be minus 32.5K, minus 1.81K, and minus 1K, and that will be minus 35.31K. So since the EUA of proposal B is bigger than the annual cash flow of proposal A, so we choose proposal B. I think that is it for the annual cash flow analysis, and thank you very much.